morning, sir.
Morning, sir.
My name is
You can check your jottings. No problem.
my name is Flight Lieutenant Sahabi Musa. I'm from Nigerian Air Force. On Tuesday, you talked to us about overview of infectious disease and malaria modeling. You start with an opening statement by Sir Ronald Ross,
Okay.
a doctor, who said, as a matter of fact, all epidemiology concern as it's okay. You talk about mathematics has to be considered when we want to talk about epidemiology.
All right.
You went further to tell us but why modeling to plan outbreak. You talk about check about the spread, the severity, the effectiveness of intervention. And you said, what type of model do I need? Then it all depends on your research question, the type of things you want to do. You mentioned statistical model, dynamic and math model, health economic model.
All right. Thank you.
And so on.
Yeah, good. We try. Yes. Next person. Yeah, you said what you want to say. All right. Okay. There is someone there. Okay, I'm coming. Okay.
Good morning, Prof.
Yes.
In addition, my name is Dr. Roslyn Ndu from River State University, Port Harcourt. In addition to what he said, there is not enough to know the mathematics. Basic, very important, we must know the history and the background of our problems.
Right. Right. Thank you. Yes, the young man here. There's one young man here from Ogun State, Ali.
Good morning, bro. My name is Daniel Akiemi. So from the section on Tuesday, we talk about our data and we said data are dumb and can only be spoken through models. And we talk about whenever we are modeling, there's always a limitation. So when we are modeling, to speak on our limitations. So also talk about the formula for HIT, which is 1 minus 1 over R naught. So that is just one of the things I need to know.
Okay. All right. There's someone there. Last person. Thank you. And then if I'm going to teach the same math, general mathematics, to people in arts, I should teach it with examples from their field, maybe from literatures, from classics and all that. So it will make them to see the importance of mathematics. And then if I'm teaching people in commercial, but the same mathematics, now I'm teaching them the same theory, but the application now, I'm now applying them to maybe accounting, to banking and finance. So when people are finishing from secondary school, everybody knows that math is a language, just like English is a language. And you know that anywhere, because what could have made maths to be meaningful to us, because most people in biology, they always maths has been well explained to the point that you can apply it to real life. Math should be taught so that everyone can find his own space and will not see math as something that is just there. Let me just like the DVC on Monday was saying that let me just have CCs and leave this thing and go. But when you know that the math you are doing can be applied to sociology. Someone was here yesterday, I think he came to me and said is it linguistics? I said there is mathematical linguistic. I told him, yes. So, yes. So if you find an area, mathematical psychology, sociology, the DVC was talking about banditry, kidnapping. There was this student of mine, undergraduate, that did something on modeling kidnapping some years back. It's possible, like kidnapping, migration, modeling. These are things that if somebody has, even if you are in sociology and you have a very good maths background, that I've been able to explain to you the association between math and sociology, why you are from, maybe you will find it easy to flow in that area. Now, what are we doing this morning? Now, the mathematical modeling we are doing is actually just bringing some aspect of mathematics to the same thing for insurance. I can do the same thing for banking, because I need to know the question I need to answer and the relevant math that I will need to use to respond to that question. Now, and then we also discussed something on which, when it comes to epidemiology and using mathematical modeling, what is the interest of the public health? What are they looking for? The mathematicians also have their wish list. So we begin to see that, the mathematician is interested in doing some qualitative analysis and proving some mathematical phenomenon and all of that. At the end of the day, that thing, even though I'm developing a model of malaria, at the end of the day, it's still focused back to mathematics, because I'm now developing theories of mathematics to answer questions, to do modeling, but not necessarily answering operational questions. Now, there are two aspects of modeling. I call it academic models and operational models. Academic model is what many of us are doing in the university. You are publishing the paper, but you are not, the work is not being used by anybody. It's not informing or guiding any policy. So now, for us to move from there into doing what will be relevant to people in the public airspace, we need to do operational models. And that's why my direction out the rest of this my talk is going to focus on operational models. Models that people in the public, if I'm explaining it, they'll be able to see light in what I'm talking about. They will not be seeing center manifold theory. I have used center manifold theory, but I will have used it in a way that just like you are carrying your computer, or your laptop, everything about it is mathematics. But you are having the product in your hand. It's a product you are having in your hand. Huh? But if you inside, the complexity around the laptop is math. It's Boolean algebra. But you are not seeing the Boolean algebra. You are seeing your ABC. You are typing your and you are enjoying it. So the same way we must present modeling. If you are not presenting modeling like that, nobody will buy it. Nobody, it will not make sense to anybody. But I think that's the idea behind this. Now, we are looking at modeling process. The modeling process is an iterative set of steps, mainly consisting of the 4 overarching areas. The one is problem formulation. Problem formulation. I mentioned it earlier. Problem formulation, including defining the modeling question. Problem formulation. Now, if you are carrying out a modeling studies, you start from problem formulation. You must know what you want to do. You must understand what you want to, the problem you want to solve. You cannot tell me that, you are having a paper. Then I want to develop a compartmental model. Would you want to develop a compartmental model? So the question should be that problem formulation should come from, like, take for instance, I'm working on cholera. It should come from modeling of, from the biology or epidemiology of cholera or immunology of cholera, depending on what I want to do. And then I'm talking about, what is the transmission pattern of cholera in Ekiti State? That's why the problem is, I'm beginning to talk the language of epidemiologists. Or what are the prevalence or incidence of cholera in a particular state? Or what is the burden of cholera in a particular place? And then, in doing that, you also have to have in mind that you need data to do that. You need data. Now, if you are defining a problem, the problem should be location bound. You should have a location in mind. That, okay, maybe I'm working, or I'm going to work on a particular local government, even if it's Oye local government. Or I'm working on a particular state in Nigeria. Or in Kenya. Lona. Like in any town in Kenya, in sub-district in Kenya. And then I'm saying data contextualization. I need to think about to solve the problem. What kind of data do I need? Now, sometimes if I don't have, can I get a pen? I'm sorry, a blackboard, a whiteboard pen. So if I have an incidence data, now let me even start. What is incidence? If I say incidence, what does it mean? No, it's wrong. That's not the real definition of incidence. That's a layman. The total number of new cases over a period of time. So it means that you have to mention that period of time. That's why it's incidence. And it's always longitudinal. Now I'm taking the incidence of maybe cholera from 2015 to 2026. And then it could be daily. It could be daily. It starts from daily to weekly to monthly and yearly. Although yearly may not be useful because so many information is lost. But at best, monthly. So if I'm doing that, I have a lot of data to play around with. So I'm looking at incidents. Now, incidence data, where are they? Where do you get them? Where do you get incidence data? Where do you get incidence data? From the so they are collected from the hospital, from the primary health center, from private hospital, and then like for malaria now, they have this what we call NMDR, National Malaria Data Repository. So, and then all the hospitals in every state, they send their data to there's a particular platform, and then from there they load it. So you find out that. So I'm having something like this. Now this is cholera cases, maybe in thousands, right? In thousands. And then this is period from 2000, year 2000 to 2026. That's roughly 26 years, right? So you have this kind of data, and this is the time. It's time in maybe in months over this period. So maybe your graph is looking like this. Just to give an example, because the data is collected every month, and then you are having a oscillating graph. So there are times there's a peak, and then there are troughs, and then there are peak. And this is showing a kind of seasonality, especially if it is a repeated one, repeated, and also regular. Then you have seasonality. It is repeated and regular. That means maybe every March of maybe March 2000, March 2001, March 2002, March 2003, March 2004, you have a peak. That is seasonality. So it is repetitive and it is what? Regular. So when you have this kind of thing, you see that that's it. This is just the data. I'm not talking about the model yet. This is data. So if you have an incidence data, then you already know the kind of data you have. You have cleared all the missing value. You have been able to see the nature of the graph, the summary statistics of the graph of the data, and you have also cleared all the outliers. So the outliers, you have done something around it. I may not be able to talk about data wrangling and all of that today, but before you place any data to be used, you have to work on that data so that places where you are seeing strange extreme values, you have to do something to them. There are methods of taking care of that. One of them is spline. That's a spline analysis, or interpolation. If you have, strange values in your data that can make that will not allow your model to be able to be fit with the data. So you have to. So if you are working on data work, you have to data modeling. We call it data modeling. So you have to work on your data first, clean your data, do all kinds of things you need to do to make the data prepared for use. So one thing you will discover about this kind of data is a time evolution data. Time evolution over a period of time. So this is what we call time series plots. So I call this one time series plots. Time series plots of cholera cases. 2000 to 2026. This is a time series plot. Right? So, okay, are you the one changing my slide? Now, this is not the only kind of data you may have. Sometimes, if you are working and you don't have incidence data like this, like we are doing was given to the NTD group, that's on schistosomiasis in Abuja, and the data they have is not over time. It's over age in years, demography, and then schistosomiasis cases. The data is not over time, it's over ages. That's another. So for that, we have what we call prevalence. What do I call it? So what is prevalence? Okay, good. Yeah. Good. Okay. Both new and old cases together. Prevalence at an instant of time. Instant of time. Like, so it's static. Incidence is dynamic. Right? Prevalence is what? It's static because age is static. Time is dynamic. Time change. You understand? So now here you find out that now that's why a lot of modelers, you know, when you get to data use, you get confused if you don't know how to differentiate between data, to know the kind of mathematics you are going to apply. But if you don't understand the data, your maths will be useless. Now, this kind of data, let's model for this is a continuous time model for this kind of data. Continuous time model like what? Like ODE, dx, dt, right? Let me give you like this. I can use a continuous time model for this, right? Like SIR, ds, di over dt, dr over dt. Continuous time because you see the time is a time evolution. So you can use this kind of model, SIR model, for this kind of stuff. But for this, if I have this kind of data, I cannot use this to capture, to be able to fit the model. Because this is prevalence, it's static. This is incidence, it's continuous. So I will need to use PDE that has age and time, right? D that has age and time. That has age and time, PDE. So in other words, what I'm going to do is that because there is no time here, so this one's supposed to give me like something like, I'm just doing just a normal sketch of it, right? But because this data I have does not capture time, so time is 0 here. So I only pick this. So I have a total of ds. So in other words, I'm going to have dsa all over dA. So that's what I'm going to use to capture that. So it means that I'm looking at age, not time now. So I've abstracted it from the PD. So I've abstracted this part because the time here is 0. I don't want to use time. It's not time evolution because the time is just at an instant of time. Maybe I just collected the data within what's it called? From January. Maybe I collected some in January, some in May, some in June, like that. Or maybe within a short period of time. I don't have a time evolution. Maybe, or even I collected one in January at a particular time in January. Then in February, I took some. In March, I took some, like that. And then maybe within 3 months, I have all my data. If it is questionnaire, between January and March, I have all the data with me. And then I have it as a questionnaire. So it's fine. In fact, it may even be within 1 week. I just spread it to the whole, maybe the whole state or the whole local government, and I got the data and I have it with me. So it's not about time, it's about the demography. Maybe in terms of age or any other thing, but most times, I mean, age is very important because you find the ages of people, how the thing is spreading in different age groups. So for this kind of data, which I call incidence or cross-sectional data, I'm sorry, prevalence or cross-sectional data, because it's not time evolution. So now maybe I should move. When I get later, I will still explain some things on this, but these are things you have to know about different kind of data, different kind of mathematics. So if you don't know how to undo a data, especially experimental data, all this kind of lab data, what kind of maths can I use to capture them? You will be confused. And that's where the problem normally starts from mathematician. So now, then the next step is model development. After you have, so it means that I need to understand my data first before I talk about the model. So if I'm not clear about my data contextualization, then I don't talk about model. Because if your data is bad, your model will be wrong. Model development, then I also look at model fitting. Model fitting. So, and what do I mean by fitting? I mean calibrating the model with the data. I'm going to talk about it. Then in the process of fitting, I do some parameter estimation of certain parameter in my model that are unknown. They are unknowns. And then before I can do scenario formulation, I need to do what I call cross-validation. Now, there are different kinds of validation. So, but the one I'm talking about here, you can also do other ones like internal validation. You test their performance metrics with certain method. I'm going to talk about them later. MAE, MAPE, all of them like that. And then you talk about scenario formulation and results. This is the process an operational model must follow. From problem formulation, which include defining question, data contextualization, model development, fitting, validation, and scenario formulation and results. Let me tell you, to do an operational model, let me tell you, it's more difficult to do a theoretical model. To do, because you are dealing with real life data. To do, because now, if you are doing a mathematical something, you know where you are going. You are working towards something. But this one, when you get the data, by the time you do your modeling something, you can enter the bush. Yes, and come back. And then if you don't have somebody to guide you, you can be in this for the next 2 years on one question. I can bet you, yes. Because if you don't have a guide, a proper guide, that have somebody who has been maybe, you understand? If you are because most times what you are expecting is not what you will see. Because the data are filled with uncertainty. So you are now trying to use a model to capture it. Now that model, you have not tested it before. Whether that model can be useful for it. So sometimes even people have to do more than one model, which I call model comparison. I'm going to talk about that later. 3 models to compare the data you have before you can get a meaningful stuff. So you find out that you have more time. When it comes to data work, it's not a straight line. So that's why most people who are doing mathematics, they prefer to go and do their theoretical. Let me tell you, if you are doing theoretical in CAMDA, we'll have 1 million paper by now. Because as I'm here now, I can develop different models and theoretical that we even put secondary analysis, and we'll do it. We'll do the global stability, everything. We'll do that one. It doesn't take 1 week. Do that one and be sending paper but when it comes to data work, you can't try it. One of my students has been trying to respond. We sent a paper. Samuel, how many months now? We sent the paper, and for you to revise, how many months? Is it 2 months? The one they asked you that submit today, Is it 2 months? Tomorrow. Is it 2 months? But when did you start the work? Say you understand what I'm saying. So it's not, so that's why so many people run away. You just want to do small thing. But at the end of the day, if you do that, nobody will use what you are doing. You just do it just to make yourself happy. But if you want to do something that, like, people in the program can say, bring that work, we will include it in our policy. Then you have to sit down tight and do the real stuff. It's not always an easy thing, but it's possible. So model development broadly involves sub-steps, including parameter estimation. Parameter estimation, addressing uncertainty in the model, on addressing uncertainty, because parameters are always tending to more uncertainties. So you have to, the result of your parameter must not be point estimates, they must be interval estimates. And then it also involves model validation, model development. Then a diverse set of modeling team members, including policymakers, should be included from the project assets to inform all stages of the modeling process, including the model design. So if you are carrying out this kind of work, because it's a policy-driven work, it will be good that you involve people in public space from the onset. So as you are developing the model, they are telling you that this one is not realistic. This one is realistic. So you are carrying them, you are going together. Do you understand me? Like our work, we do present, at least they have every monthly meeting. So we present at intervals during their monthly meeting, where people, some of us will come and then that's a SMEO, that's surveillance, monitoring, and evaluation and operational research. For that's National Malaria Immunization Program. They critique some aspect of the work. We go back and we check, we look at it. So that's why most times our work, they are always included in our publication. So you find out that for you to do that kind of work, it's not something you just do alone. You sit down in your room, you develop the model, you write all the code, you do everything, and then you submit. You did everything. You didn't consult anybody. That model cannot be useful for policy. Next, I can't move. Okay, yeah. So the modeling process includes problem formulation, step 1, definition of the modeling question, then data conceptualization, then you have model development, fitting, and validation. Under that, you have model development and parameter estimation. Then we have model validation, scenario formulation, and results interpretation, which involves scenario analysis, interpretation, and evaluation of results. Now, another aspect is the scenario analysis. I'll be talking about that. Let's move on so that I wouldn't waste much time, because I was still going to talk about each of those steps. Now, interpreting and evaluating modeling results. There is no single correct model for all types of policy. And the appropriateness of a model could be determined primarily based on the question. Now, whether your model is appropriate has to be determined by the question you have posed. What question are you trying to respond to? Now, if your model did not respond to the question, you have not done anything. If you have posed a question at the beginning and you finish the results and you went back and you check your question, and when you look at question and you look at the results, what came out? What's the outcome? Can you say that the answer you got respond to the question you pose? It's not that you say 2 + 2 and then you started writing. At the end of the day, you got 10. Do you understand me now? You said, what is 2 + 2? Right? So by the time you are doing all your analysis, your data, everything together, you now got 25 or you got 22. + 2 is 22. That's your result. Don't you think that is a problem? when you look at the local context, you are comparing your work with the local context of that location, everything. You are even saying, your model is even saying that when there was no rain, your model was saying there is rain. So there is a problem. So you will have to go back and check whether the model you have developed is having issues, or whether there's a problem with the data. You have to go back. So because your question, if it is not answered, you have not finished the work. So for empirical evidence, we can assess the level of certainty regarding how the true effect is close to the study's estimated effect. Now, what do we mean? If you are carrying out experiment, that's empirical evidence. Experiment in the lab. You can do this second one. You can assess the level of certainty regarding how the true effect is close to the study's estimated effect. Because you are in charge of that lab, you can control what is going on in terms of the equipment you are using. So you are checking the true effect minus the estimated effect. You are looking at it together. You can control that. But when it comes to modeling, for modeling results, this is not often possible because models produce assumption-based estimates. Assumption-based. Now, every model is limited by its assumption. So, the estimate I'm getting in my model, you have developed your model, you have developed your model on the same question. I've developed my model, different models. Now, those models are based on each of our assumptions. Do you understand? So the estimates I'm going to get in terms of maybe the scenario or some parameter value that are estimated, they are going to be within certain confidence or predictive interval. Where's my or confidence interval? Oh, it's here with me. I'm holding two. So you find out that maybe take for instance, in the model, I'm coming out with I'm saying that number of cases that will be averted after my own scenario analysis is, if I'm bringing in some intervention, maybe like wash intervention, like hygiene, personal hygiene, some other, like, or using a oral vaccine that they give them. So I have maybe in a particular location, I'm having 2,000, between 2,500 and 5,000. That's what my model says, right? And then your own model is saying between 2,000, let me say 2,700 to 4,500. And then the third model that you came up with is saying 1,800 to 5,000, right? Now, these are different scenarios in terms of the number of cases that will be averted. They are different. You can see the result, the outcome is different because our different. So, but one thing you will find out is that because you place a bound, both upper and lower bound. Now, that's why if you are doing modeling, now you must understand, especially with data, you must understand how to use interval estimate rather than point estimate. I'm going to come to that in your results or your estimation. Now, if you don't learn how to do that, you are giving, maybe after using this particular hygiene, 2,000 cases are going to be averted, 2,500 cases are going to be averted. And then that's in the model. The model gave that. But in the real life, by the time everything happened, you have said that, but we, the three of us that have developed the model, we have said this, but you came up with the model and said 2,500. That's a point estimate. But this is an interval estimate in the sense that our output is given within certain interval. So the first one said 2,500 to 5,000. The next one between 2,700 to 4,500. The third one 2,800 to 5,000. Now, but your own said 2,500. So when in the real life, by the time they are now casting the number of cases that were averted, it was 35. Do you understand me now? So if it was 35, is this one right? Is this one right? Is this one right? This one, is it right? Because he gave a point estimate. But this one, now, it means that the public health people will prepare we make plan with these intervals. Are you getting me now? They make plan with that interval. They don't make plan with a point estimate interval because it can fail. So that's why you need to introduce uncertainty into your model when you are doing your model, because life is full of uncertainties. That's why if you are flying from Abuja or Akure to Abuja, they will give you estimated time, as it's always within an interval. They don't tell you we will land at exactly 1 p.m. No, no aircraft does that. So, for modeling results, this is not often possible because models produce assumption-based estimates of hypothetical scenarios. Just like the scenarios are given now, cases averted. The number of cases averted due to some interventions that we use in the cholera model. So, and do not report observed facts or test scientific hypotheses. So policymakers should ensure decisions are well informed by carefully considering the model's intents. So the policymakers should ensure decisions are well informed by carefully considering the model's intents. What is the reason behind the model? 2, methodology. What kind of methodology they use? Now, it was one methodology that gave this guy his own result, which didn't work. Another methodology we use that gave us our own result. So, which means that they are interested in the methodology you use, the assumption that you made, are they actually based on the biology or the epidemiology of the disease, or they are out of it? And then the data sources, where did you get your data? Where do you get your data? So they want to check. And then the sources of uncertainty, they want to know. Now, if a question cannot be answered through modeling, other research methods may need to be used to answer the question. We will look at that. I'm going to round up now because my time is done. Next slide. Last. I'll stop on that slide. Let me see what is there. Okay, I can't again because this will take time. Questions?
Let's put our hands together for Prof for that. All right, so are there questions? I want to take 1 or 2 questions, so I'll count. 1, 2. Four. Okay. 4. All right. Number 1, 5. Okay. Let's.
Good morning. Thank you so much for this insightful presentation. You were talking about the director with respect to. So I was going to ask that when do we use PD and when do we use OD with respect to disease modeling, and which one is the most efficient and why?
Okay. All right. So, like I was saying, when it comes to operational models, like after the question, your modeling question, you must be able to look for data. Now, the data available for you will depend on the kind of model you will develop or the methodology of your model. So that's why in this kind of operational stuff, you need to be familiar with different kind of data. I've not explained, there are different other kinds of data that I've not really talked about. So that's where the problem is for mathematicians. That if they give you a special, it's only if you're familiar with working with people in the public health or epidemiology or with them. Now, in this case now, you find out that I drew two graphs. This graph was talking about time evolution because it's an incidence data. Now for that, I need an example, the basic one that is homogeneous is ODE, right? Homogeneous. OCI, you can use that. You can, and then if I have a data like the second one, maybe that was collected at a point or at an instant of time. So that one you cannot use a continuous time model. You need to introduce a PDE because PDE captures, it can capture location, space, and time. It can also capture age and time. So because I'm not dealing with space now in terms of location, my interest is capturing the age groups. So what do I need to get, because the data has the age stratification in the data. I know all the ages they have collected. So maybe between age 0 and 80 years, they have grouped them. Age 0 to 10, 11 to 20, 21 to 30, like that, something like that. So I have the age, and we can see how the diseases were spreading among the age group. With that kind of data, I developed this OD. And then this OD can capture time, but in the model, I did it, sorry, in the model, I didn't have time. So I removed the time aspect and I picked the age. So the age would now be where I would develop the I think that's all. So instead of DST, it's going to be DSDA. Do you understand me now? So, and then, and not time. Because my data is in age. Okay? So that's it. So, but in terms of, most of the epidemiological model don't actually speak like that. Do you understand? PDs like that. But the only way I can is this kind of division that I made. I explained on the board in terms of when I have the data. You see that the data, the model.
All right, number 2. Okay.
Thank you so much, Prof. My name is Andrew Rains. You talked about sitting down with stakeholders and policy makers when you're modeling for policy issues currently in Abuja. I'm volunteering for pollution in the federal territory to predict what will happen in the next year. We try to get the attention of stakeholders in the Ministry of Environment, Ministry of Health, and other persons. It was difficult, even though we have all the ethical approvals to this stuff. Is there something you're doing right? Because this is a pilot study, and it's a study. Completion of this pilot study will take more other states in the country so that we don't kind of challenge. Maybe there are certain knowledge you can share, the things we can do better in case of next. It took us about 4 to 5 months for them to even key into what we are doing. Thank you, sir.
Yeah. So you are the one that have identified the problem. You need to, there is politics of science, right? Because somebody you want him to, you said, well, maybe you have a grant, right? You have a grant for this work. Okay, no grant. You are just doing it. So you need to let them know, okay, since you have no grants, what will be their benefits? Do you understand me now? Where an average that's that guy is thinking that all these things you are disturbing me about, what's my benefit of money? Is it come in terms of paper? Are you going to involve them in the paper by the time you publish it and things like that? So they want to hear that as a bait. Yes, because if you don't do that, they will not listen to you. And then you are the one that is interested in doing what you want to do, even though you said it's voluntary. You understand? But eventually, you are the one that will make sure that they understand what you want to do and how you can integrate them and make them believe that this thing you are doing, they will also benefit either short or long term. Because if you don't do that, you are not likely to get their attention. That's why it's been difficult. You understand? Like the people we have been working with, when we publish any paper, we send it to them. So the more we do that, the more they became open. Do you understand me now? We sent about 3 or 4 papers out, and then we put their names there. So when I sent it to them. So when they saw it, they say, wow, we are bringing our next meeting on so and so this, and we'll pay your. Because the reason is because, one, they are seeing we are answering some of the questions, and then we are putting their name. We are not giving money, but they gave us data. We have access to the data. So for us to gain more access, we need to, even before we got the data we did. Do you understand me now? So those are the things. We're not giving money, but you have to find a way to attract them to believe in what you are doing. These people, if somebody is coming from abroad to come and do the same thing, it's not the same attention they are giving you, they will give it. So what do you think those abroad people are doing to get there? What do you think they are doing? So you have to learn. Thank you.
All right. Thank you very much, sir. Number 3. Okay. 3. Let's take 3. Let's follow.
Okay.
Thank you very much, Prof. It's an eye-opener this morning, but I just have a kind of concern when you talked about data cleaning, especially when you have outliers. All right, so I know we are talking about public health data here, but there are some data or some scenario where you need to be very, very careful with cleaning the data. There are some extreme values that in the reality you can do without. I'm talking from the perspective of finance. Most of the data, most of the data you have in the public health, they are smooth and continuous.
No. They have a lot of noise too.
Oh, they have noise. Okay, so but in finance, we have so many noises. And then not only that, we also have jumps. And if there's an end to which you clean the data that you will make it not to have noise at all. And when you come back to the real world, you have watered down the reality.
Yeah.
Now, there was this recent paper I did with a friend on the post-subsidy exchange rates in Nigeria. When the subsidy was removed in 2023, we observed that by our plots, all the exchange rate with Nigerian Naira exchange rate jumped sporadically. Immediately, our old man Uja announced subsidy removal. From that day, there was a spike in Nigeria, naira, dollar, naira, euro, naira, pounds. And after that, we observe large jumps in the post era compared to the new era. Apart from the trying to say is, if we get that data and say, okay, this value is too high. Why? Let's clean it. So I want you to help us. I know you are not in finance, but help us throw more light. We are here to learn. Thank you, sir.
I'm entering finance now. So what I'm saying is, right now, as long as it's data, now any data, one of the things, there are two major things about missing value outliers. There are two major issues about data, right? So now there are occasions where you see certain extreme values that you need to ask questions from the people that gave you the data. That maybe this thing is actually there. It's possible. So that's why we don't just say that when you see an extreme value, you just quickly remove it or you reduce it. No. It may be a red flag that you need to really work on. So but when you are having missing values, do you understand me now? Like missing values now, that one can also affect your output. So there are methods of fixing missing value in data, like mathematical or statistical method. One of them is what I said, spline analysis or interpolation method, that you need to fix those missing value. You understand? But when it comes to extreme values, you need to check why this before you now go ahead to do your further analysis. Because if you don't check and you just decide to do your analysis from there, it may affect your output at the end of the day. So I think that's the way. So one of the way to also check is to maybe from the source of the data, where you got the data from, or check from previous work that have been done, related work. How did they capture that same kind of data? And then from there, you can get some light over it. Thank you.
Number 4.
Okay, sir.
Just to add to the reason for the spurious data she possibly had in her finance data.
Okay.
She mentioned subsidy as a particular variable that influenced exchange rate. Well, I just want to remind her that when the president removed subsidy, it wasn't just subsidy. The exchange rate market was controlled by the central bank then. So after the removal of subsidy, he also freed the naira, that is, allowed market forces to determine the exchange rate. So it's most likely that that variable was not accounted for in their data analysis, or could be a possible reason. Since the market force could be a random, could have a random influence on how the the exchange rate fluctuate. So it's most likely what's data she's seeing.
Okay. Thank you, sir. You know, like after that subsidy removal, what we observed was that initially before, the dollar rate in the black market is always higher than the CBN before. Yes. But as soon as that happened, it almost become the same thing. So, and that may also be an hotspot or a red flag for what was going on there. Yes, next one.
Thank you so much, Prof. So earlier you were talking about understanding your data, like part of data contextualization before even know the types of model you're going to create. So I want to ask, is it possible to be working on a modeling project where you don't even know the type of data you have or you're going to need, and then you have to develop the model first to now maybe go out and go and collect data? And if that is possible, like what are the procedures or what are the steps to be taken? For example, let's say you are working in an area where let's say there's no data for it, and then you are trying to see how you can bring in mathematics to like capture some dynamics. And then after bringing in the model, after developing maybe a framework for the model, now want to go and collect data or maybe survey or other types. So is that even possible? And if that is possible, what are the procedures that we're supposed to follow?
Yeah, it's possible, but it's a difficult part. It's a difficult part because you have already developed a model for the data you don't know about. Now, at the end of the day, you'll find out that by the time you get the data, are you hearing me? By the time you get the data, you will now be struggling between the data conformity and the model. So, and then at the end of the day, let's assume that the data you now got has a lot of missing values and a lot of extreme values like outliers and all that. So you now start the process where you are supposed to start from before that you now go back there again. It's like begin again, because you cannot use a data that is having that kind of issue. You have to start all over again by cleaning the data, working on the data before you now say you even want to use it to carry out any further analysis. So most times we face that challenge. Actually, we don't have a data. We are working on modeling and all that. But I said yesterday on Tuesday that as a mathematical modeler, you can also model and do analysis and without data, but you are going through another route. That route is you are going into qualitative, that is academic model. You understand? That's not operational model. So you can do that and publish it, and then if you do it well, if it's something that you did well with a mind that you want to still do further analysis on in terms of getting data, then your model analysis should guide us on information about the kind of data we should collect going forward. Thank you.
Number 5.
Good morning, everyone. In your second graph, you made mention of point prevalence not having to do with time, and you really emphasized on point prevalence. My question is, prevalence has to do with a specified time. So how do we model periodic prevalence, and what's the difference between periodic prevalence and incidence prevalence?
Okay,
thank you.
So from the word prevalence, you know that it's both old and new cases, whether it's periodic or point, right? So when you say periodic, most of the DHS data, they are periodic prevalence. That's where they are collected. Some you find out that they collected 2021, like MIS, Malaria Indicator Survey, 2021, 2020, 2024, in patches like that, 2020, up to 2021 or 2020. I can't remember the last year, 2024. You know that is a kind of periodic prevalence. Where's this thing? So when you have that kind of stuff, where you have, you have, this is cholera, let me put it like that, and then collected, you have data for 2021, or maybe 2019, 2021, and then 2024. This is time, right? This is time stuff. So you can only have something maybe here, or let me put it here, and then maybe here, something like this, right? Because those are the few points you can have for this kind of data. Well, you can use this kind of thing, but there are so many information that is lost. So you can, for this kind of thing, you can still use the SDT because it's over time. The only challenge is the time interval is different. You understand? But it's still continuous. You understand? 2020, 19, 21, 2024. So it's different from that one at an instant of time. Okay?
Yeah, let's put hands together for Prof for that beautiful and wonderful session. Thank you very much, sir. All right, so we'll be